Alright, for today's Algebra 1 lesson, it's lesson number 75. We talked about solving quadratic equations by completing the square. Okay, so we've been talking about solving quadratic equations using all different methods. So we started with factoring and taking the square root. And now this is completing the square. So this is when maybe factoring isn't the nicest option or it's not obvious what the factors are. You can always use this method. Or anytime that you can factor, you can also use this as well. Okay? So just for some background in class, I think we were kind of confused on what completing the square was actually doing or why we do it, kind of where it comes from, this like out of thin air idea. So here's some background for that. Basically why it's called completing the square is because sometimes when we have trinomials or we have quadratics that look like this, we want to factor them, and we can do that using Xbox, right? So we would do our 1 on either side here, the AC, which is still just 1, goes there, and then the B term goes here. Then we would look for factors that multiply to 1 but add to 2, so that's exactly 1 and 1. Looking at these factors, I have exactly x plus 1 times x plus 1, or x plus 1 squared. Okay, so that's what we call a perfect square binomial. Okay, so this trinomial, we were able to factor it into this perfect square here, and that's nice. It looks nice, and it can be helpful to have this a double copy of something instead of, say, two different factors like x plus 3 and x minus 2. Okay, so what we're doing now is we're trying to create this. So as a picture, we might say, okay, x plus 1, so if this was just x times x, that would be x squared. It'd be a square. If we were making our rectangle, how we multiply the polynomials, if we were doing them like proportionately, right, that would have the same size, so it's an actual square. But then we have 2x. So if I put one of the x's over here, right, if I make this x plus 1, like the factor, and then x plus 1 down here, and I look at these pieces, that gives me x squared. This is a plus 1x, this is a plus 1x, so I have x squared plus 2x, and then this little piece that I need to complete this square, to finish it, is exactly plus 1, right? It's 1 times 1 down here. So this is kind of the idea behind it. This is the kind of geometric concept, is actually completing this square. So we're going to look at where we just have an ax squared plus bx, and we want to find this perfect c that fits in so that we can write our factors like this, right? Write it with a perfect square. Okay, so another example is if I have x plus 6x, I want to factor that into a perfect square. I start with cutting it in half so that the side lengths are the same. So I have x plus 3 and x plus 3. That gives me x squared and then 3x on each side, right? I'd get my x squared here, 3x, 3x. I'm sorry. And I know that this little piece that I'm missing is 3 squared. So if I were to make this plus 9, then I can write it as x plus 3 squared. Okay, so that's what we're doing. Why the purpose of this is to kind of manipulate the equation that we're given by adding some constant to it in order to make a perfect square binomial. Okay? Alright, so moving on now. Here are the steps for today. So if you weren't in class, take a second and write these down. This is an important number. That's that special number that we want. We're going to take whatever the b value is, we'll divide that by 2 and square it. That's the constant that we would add to both sides. Okay? And then this is what the perfect square will be, right? If we were to factor it, that's what we'd get. And then we'll continue by solving it like a square root problem. So we'll take, or like a square problem, we'll take the square root of both sides, make our two equations, and simplify. Okay, so again, remember, we're thinking about these as ax squared plus bx plus c. So a is going to be the coefficient in front. For today, that's just going to be 1 in all of these, and then b and c are there. C is kind of what we're trying to create using b. Okay, so starting here, I'm going to start by moving all the constants over because I want to create my own new constant. So I'll subtract 24 over here. That gives me x squared minus 14x equals 24, or negative 24, excuse me. Okay, and I'm going to rewrite this, and I'm going to leave space now to complete the square. So I want to use that special number that's going to let me write this as a perfect square binomial. So that's going to be, using my steps, I know that I'm going to take b and divide by 2 and then square it. So negative 14 divided by 2 is going to actually just be negative 7, but here I wrote it as negative 14 over 2. And then I square that, and you want to make sure you're always doing it to both sides to keep it fair, right? Okay, so moving on from here, I would rewrite this. Negative 14 over 2 again is just 7, so that's just plus negative 7 squared. And negative 7 squared is just 49, so I'll write it like that for the right side. Okay, and then remember our perfect square binomial is just x minus 7 all squared. Okay, so again, x minus 7 on the left, that binomial squared, and then negative 24 plus 49 is just 25. Okay, now I'll take the square root of both sides and set up my two equations. So x minus 7 equals the positive square root, x minus 7 equals the negative square root. Square root of 25 is just 5. So I have x minus 7 equals positive 5, and x minus 7 equals negative 5. Adding 7 to both sides here, I get x equals 12 and x equals 2. Those are my two answers, and I'm moving on to number 2. The first step here will be to add 57 to both sides. That will give you n squared plus 10n equals 50. Okay, and I'm going to rewrite it, leaving space for my special number that will help me to complete this square, which for this one is just going to be 10 over 2 squared, right? That's my b over 2 squared. I need to put that on both sides. And I get n squared plus 10n. 10 over 2 is just 5. 5 squared is 25, so I have 50 plus 25 on the right. Okay. Then I can get my binomial squared from the left side. I know that's just going to be n plus 5 all squared. And then this 50 plus 25 will just give me 75. Okay, then I'm taking the square root of both sides and setting up my two equations. So the equal to the positive square root equal to the negative square root. Square root of 75 I can rewrite as the square root of 25 times 3. That 25 comes out as a 5, right? So this is just n plus 5 equals 5 root 3. And I subtract 5. When I do that, I need to make sure that I don't try to combine it with this. Okay, those are different things. This one's being multiplied to root 3. So I can't just subtract 5, okay? 5 times root 3 is like 5 times 1.7. So it's about, it's a little lower than 10. So if I subtract 5, then I only have 5, and that's not the same as root 3. So we just can't do our math that way. They need to stay separate. So that's my answer. And then over on the second one, I subtract 5 again, and I would get negative 5 minus 5 root 3. And you can see that these answers are very similar. All that's different is the sign here, right? It's positive here, but negative here. So we could rewrite that if we wanted to, just to kind of put it all together. We could write it as n equals negative 5 plus or minus 5 root 3. Okay, so those two answers join together into this one line, but it's still two solutions right here. It's still accounting for the positive and negative. All right, so moving on now to number 3 and 4. Number 3, again, I start by moving the 7 over to the other side. I'm going to write this, leaving room for me to complete the square. And do the same thing on the other side. Completing the square, I get -3 for my b over 2. And then I know I'm looking for something to fill this in, which is just going to be a minus 3, right? It drops down, so a minus 3 and then 7 plus -3 squared. -3 squared is just a positive 9. So I have 7 plus 9 equals 16, and then a minus 3 squared on the left side. Now I take the square root of both sides and set up my two equations. That's a minus 3 equals positive root 16, and a minus 3 equals negative root 16. Root 16 is, of course, just 4, so this is a minus 3, sorry about that, a minus 3 equals 4, and a minus 3 equals -4. Adding 3 to both sides, this side gives me a equals 7, and this one gives me a equals -1. Okay, number 4, I add 57 to both sides, and I leave room for me to complete the square. Half of 6 is just 3, so I know that's what's going in my parentheses here. That drops down to become m plus 3 squared. And 55 plus 3 squared is 9, so that's, 3 squared is 9, so 55 plus 9 gives me 64. I take the square root of both sides and set up two equations. That's m plus 3 equals the positive square root, which is just 8, and m plus 3 equals the negative square root, which would be -8. Solving these, I get m equals 5, and m equals -11. Okay, so that's it for those problems, numbers 5 and 6. Number 5, I start by moving 20 over to the other side by adding it. Okay, then I am rewriting this equation, leaving space for me to complete the square, and making sure I do that on both sides. Half of b, my b here is -6, so half of that is -3. Goes in both sides. -3 squared is 9, so really on the right hand side I have 20 plus 9, which is just 29, and on the left the p minus 3 drops down. Okay, taking the square root of both sides, I set up my two equations. I can actually kind of do this more quickly if I like. Instead of doing one positive equation and one negative, I could just say p minus 3 equals plus or minus root 29. And then subtracting 3 from both sides. I just have to be careful that I don't try to combine these. Sorry, I'm adding 3. Adding 3 to both sides, I have to be careful that I don't try to combine these numbers in some weird way that I can't do. So I have p equals positive 3 plus or minus the square root of 29. Alright, and number 6, again, same thing. I'm adding 44 to the other side. That gives me x squared plus 18x equals 40. I should leave space, though, for me to complete the square. And then I get half of b. b is just 18, so half of that would be 9. That should go in my parentheses. And I bring this down. Bring this down to a perfect square, which is x plus 9. And on the other side, it's equal to 40 times 9 squared. 9 squared is 81, so this equals 121. Taking the square root of both sides, I end up with my two equations, so x plus 9 equals the positive root 21, and x plus 9 equals the negative root 21. I can combine these like I did in number 5, so that there's just one equation. Okay, when I subtract 9, before I do that, root 121 is just 11, because 11 squared is 121. So I will write it like this, and then subtract 9, so I get x equals negative 9 plus or minus 11. And doing some work with that, I have negative 9 plus 11, that gives me x equals 2. Negative 9 minus 11 gives me x equals 20. Negative 20, excuse me. Okay? So those were the problem types that we focused on in class. I hope these can help you on your homework if you're getting stuck. Another thing we can do here is I will pause here and you can work on, you should pause here and work on these problems if you're getting stuck. And then the solutions are on the next page, so you'll be able to see where you may have gone wrong. Okay, so if you want to work on these, pause here. And I'll flip to the answers now. Okay. Alright, so only a couple that have the radicals still there. Otherwise, you're going to always want to get this number over to this side, get this number over, get this number over, okay, and on and on. So you'd move the constant over and add in that special c value, and then factor the binomial squared out. Alright, well, that's it for today's lesson. We're going to continue working on these tomorrow with cases where a is not equal to 1. So I will see you then. Have a great day. Thanks. Bye.